Hello, Wednesday 1 class. This is your notes for section 7.2, part 1. This is systems of linear equations now with three variables. So we have three variables, an x, a y, and a z. Typically is what we use anyway. It's like the old xy plane. If you look down here, here's x, here's y. It's the old xy plane. But now we've got something coming up out of the xy plane, which we call the z-axis. And a point in the xyz, we call it xyz space, is a three-dimensional point. It's an ordered triple. And we write it in the same way, xy, but now we have a third dimension, z. And that point, in this case, would be something like, just kind of estimating, 6, maybe 5, 5, 5, 6, maybe 5, 5, 5, 5, 5, 6. But anyway, that's how we describe a point in space with an ordered triple instead of an ordered pair that we're used to. But if the variables are raised to the first power, it's linear, just like it was before, if they're all raised to the first power. It's just when you have three dimensions, instead of a line, you have what we call a plane. So it's a linear equation. It's just when we stretch a line in three dimensions, just think about taking a line and pulling it up out of the xy plane, and you get a plane. You get a like a rectangular shape, but it goes off in all directions forever. So this is what we call a plane in three-dimensional space when we have three variables like that. Now, one equation that has an x, y, and a z is a single plane, but if we have three equations with x, y, and z, we end up having three planes. And the solution to a system of three equations with three variables is the intersection point. Now, instead of two lines, it's now the intersection point of three planes. So where the three planes come together is the solution. Now, we obviously won't do these geometrically like you could easily do if they're two-dimensional, because of the complexity of plotting things in 3D. But we will do the other two methods. We will use substitution, and we will use a lot of elimination, or the addition method, in solving these 3x3 systems. So first of all, let's just make sure we understand, what does it mean to be a solution to a system? If this is a solution to this system, which it says it is, show that it is, it just means when I plug in -1 for all the x's, 2 for all the y's, and -2 for all the z's, all these equations are true. So this is how we show an ordered triple as a solution to the system. We just take everywhere there's an x and we replace it with -1. We take everywhere there's a y and replace it with 2. And we take everywhere there's a z and replace it with -2, and then show that when we do that, we get 9, -8, and 15 in these cases. So this is a solution to that system. Alright, and the matrix method works for this too. It's just now we have three equations and 1, 2, 3, 4 numbers that are in each equation. So when we go to the matrix menu, you should have a 2x3 system from the problems we've been doing. So what I strongly recommend you do here is when you go to your editor, don't edit this one, just skip down to B and let B be a 3 equation by 1, 2, 3 variables plus 1 number is 4, 3x4 system. Alright, notice these little dots mean you have to kind of go off the grid to be able to, or off the screen to be able to fill it in completely. But now you just plug in the numbers as you did before, 1, 2, -3, 9, and now it skips down. You just have an extra number to put in on each row, and an extra row. 2, -1, 2, -8, -1, 3, -4, 15. Okay, so there's my three equations put in. Second quit, second matrix math, RREF. But this time we're going to call, instead of matrix A like we were used to, we're going to call matrix B, because that's my 3x4. And there's the -1 to -2. solution. So the matrix stuff works for this as well. It's just a 3x4 matrix now instead of a 2x3 matrix. So I strongly recommend you take the next line, next available matrix to make the 3x3 type of equations. Alright, now if you're going to do it by hand, you are going to have to do these by hand. I'm going to have you show your work again on the final. You need to be able to do one of these two procedures. So you're going to eliminate a variable in the two equations. Alright, and the way we do that is we pick two of the three equations, eliminate a variable, and then pick a different pair of equations. Alright, and then eliminate the exact same variable. Okay, you have to make sure that you're always eliminating the same variable. And then once we do that, we have a 2x2 system. And you just solve that 2x2 system. Then you end up going all the way back to get your into any of the original equations to get your third variable. So let's just walk through the procedure for this with this next problem. Alright, solve this system. So the first thing I'm going to do, it says, is to reduce it to a 2x2 system by eliminating a variable. So here I'd have to multiply the x's in both to eliminate x. I have to multiply y to eliminate, in both equations to eliminate y, and the same thing to eliminate z. So it really doesn't matter which one I choose to eliminate. I'm going to have to multiply both equations because all these have prime numbers in them to eliminate both variables. So I'm just going to choose these two, alright, equations 1 and 2, and then I'm going to do these two, 2 and 3, and I'm going to choose to eliminate x. Okay. Now, if I'm going to eliminate x in 1 and 2, I'm going to need to multiply the top equation by 5 and the bottom equation by -3, or vice versa. One of them has to be negative because we have the same sign. So I'm going to do the top equation by 3, and I'll get a 15x minus 6y minus 12z equals 9. And then I'm going to multiply the second equation by -5 to get that sign change. Alright, so this equation times -5 gives me -15, -15, -10, and +15, alright, for each of those coefficients and constants. And now I'm going to add these two together, and I've eliminated x. So I get a -21y, a -22z equals 24. And now when I go and pick these, I switched it to blue over here. So now when I go and I pick these two, I'm going to multiply this top equation right here to get a sign change by 2. And I'm going to multiply the bottom equation by 3. And I'll have a sign change in x. And it'll be eliminated just like it was over here. So I'll get a 6x, a 6y, a 2z equals a -3, or sorry, -6 here, and then the opposite sign, which is what I wanted, times 3, 15 times 3 is 9, times 3 is 9 here. And so when I combine these two, I get 21y, 13z equals 3. And now what I end up with is two equations with just two variables. So now I'm going to take these two and create a 2x2 system, meaning two equations, two variables, and solve that system. Now notice immediately the signs for y were opposites, the coefficients for y were opposites. So I can go ahead and combine these. I'm going to go ahead and add them as they are, and the y's cancel. -22 plus 13 is -9. And then 24 plus 3 is 27. And so I can go ahead and solve this for z. So I get z equals 27 divided by -9 is -3. So I know now z is -3. And now I just use either one of these original two equations and solve for the other variable, y. So I'm going to use this one. 21y plus 13, we got z to be -3, so 13 times -3 equals 3. So going through and solving, I get 21y equals 42. Divide both sides by 21, that gives me y is equal to 2. Alright, and then finally I take z equal to -3, y equal to 2, and I go back into either one of these original three equations, and I can solve for x. So right here, 5x minus 2 times y is 2, so 2 times 2, minus 4z minus 4 times z, we got negative 3, equals 3. So 5x minus 4 plus 12 equals 3. Negative 4 plus 12 is 8. 5x plus 8 equals 3. Subtract 8 from both sides. We get 5x equals negative 5. So divide both sides by 5 and you get x is negative 1. So the proposed solution we have, the order triple we have, is negative 1, 2, negative 3. Alright, and you can plug those back into all the other two equations, all three equations, and see that it works, or remember you can also do the matrix. Alright, so I've already got it plugged in to my calculator under the 3 by 4, because this is three equations. So I've got all those coefficients in there, and when I do the REF, I get negative 1, 2, negative 3. So you can always check it with your REF on the calculator. But again, you need to be able to produce the work, so you do need to be able to do all of this. Alright, what if one of the equations is missing a variable? So this has x plus z, it doesn't have a y. What would I do in that situation? Well, remember our first goal when we did all this work before, the first goal we had was to combine multiple equations and eliminate the same variable, so we get down to 2 by 2. Well, we're just a step ahead of ourselves here. Our first goal would be to eliminate one variable in two different pairs of equations. Well, y has already been eliminated here, so I'm just going to pick these two and eliminate y here. So the way I'm going to do that is to take this middle equation and multiply through by negative 2 to get y to be eliminated. So if I multiply this middle equation by negative 2, right, I get this, and then I'm just going to keep this original third equation as it is because I want that sign changed, the negative 2y and the positive 2y. Alright, and when I combine those two equations, I get a negative x, these cancel, minus 3z equals these two combined to a negative 18. So that's the combination of equations 2 and 3. And then I just keep equation 1. I don't have to combine it with anything. So I'm just going to rewrite equation 1 underneath it here, x plus z equals 8. And then I can just go ahead and combine these two equations again because I have a sign change already. So the negative x and the positive x cancel. Negative 3z plus z is negative 2z. And then negative 8 and 8 combine to a negative 10. Divide both sides by negative 2, and I get z is equal to 5. So there's one variable. Alright, and then I know z is equal to 5, x plus z equals 8. So x plus 5 equals 8. Subtract 5 from both sides, that gives me x is equal to 3. So now I know 2 of the 3, and then I can just plug into either one of these other two and come up with y. So x is 3 plus y plus 2 times z, which is 5, equals 17. 2 times 5 is 10, plus 3 is 13. So y plus 13 equals 17. Subtract 13 from both sides and you get y equals 4. So 3, 4, 5 is our proposed solution here. Alright, so when I plug in this to check into the matrix into the calculator, just notice where we didn't have the y in the top equation. I put a 0 there. Alright, so 1 plus 0 plus 1. 1x plus 0y plus 1z. So you always have to have that placeholder there if the variable's missing. Alright, and then REF again is the last thing I did. So there's the 3, 4, 5 is our solution. Now, same thing as before. You always want to check here on the bottom, though you don't have a row of zeros. You can't have 0, 0, 0, and then a 5. So just make sure that bottom row has 0, 0, 1, and then a number for this right-hand column to be your solution. All right, third example. This one's also missing a variable, and you may be thinking, okay, well, let's just go ahead and group these two and eliminate x. And that is what I would do, but I'm not going to group these two just because I want to eliminate x. If you notice, this is a 1x and a 1z, and this is a 2x and a 2z. So the reason I'm really going to pick these two, even, this could have had something else here, but the reason I'm really going to pick these two is because when I do eliminate x, I'm also going to eliminate z, and I'm going to already be down to just a single variable, and I'll be able to solve for y. And then as soon as I know y, I can come here and find z. So when you go to pick what are my equations that I'm going to group together, look ahead and see if you can eliminate more than one variable at a time. So when I pick these two equations and I multiply the top one or the middle one by -2 and keep the bottom equation, I get opposite signs for x and z. And so when I combine them together, I end up with -7y. These cancel as well, equals -35. And I can go ahead and solve that for y. Divide both sides by -7, y equals 5. And now I go straight back up to this equation, and I can solve for z. So 2 times y, which is 5, minus z equals 7. So 10 minus z equals 7. So I know if I subtract 3 from 10, I get 7. So z equals 3. And now I know y, I know z. Now I just need to go find x. And I can plug into either of these other two and solve for x. So x plus 2y, x plus 2 times 5, plus z, which is 3. So plus 3 equals 17. That's 10 plus 3 is 13. So x plus 13 equals 17. And again, I subtract 13 and I get x equals 4. So 4, 5, 3 is the solution here. Alright, I go edit my 3 by 4 matrix to check. I don't have an x, so remember that's 0 to -1, 7, then 1, 2, 1, 17, to -3 to -1. And then last thing I did was REF, so I hit enter. There's my 4, 5, 3.